Hi, good afternoon, and welcome to the Open Data Institute. Thanks very much for joining us for today's lecture, which is Burak Arıkan, artist and entrepreneur, who's come today to talk specifically about his project, Graphic Commons, or Graph Commons, which is a collaborative platform for network mapping, analysis, and publishing. Burak's wider practice looks at complex networks and inequalities and perhaps inefficiencies in them as well. We're really happy to have been introduced to Burak by the curator and writer Yussi Paraika, who is the curator of Burak's solo exhibition at the moment at Winchester School of Art until the 24th of November, just an hour away from London. So I do recommend people go to that, where you will be able to see quite a lot of his work. But Burak, thank you so much for coming here to Shoreditch today, and I'll ask you to please come and join the podium. Thank you.
Thank you. First of all, thanks for inviting me and organizing this little session here. I will try to keep it short, because normally when I present this type of material, it's kind of loaded and there's so much stuff to talk about. And I will try to make it less about art, more about the, say, critical analysis and thinking a bit. Let's start from here. So I put a title here called as creative and critical use of complex networks, and I want to start first with what I mean with complex networks in general. So when we think about complexity and complex things in general, usually what we mean is, or what we look at is these independent agents talking with each other and interacting with each other in some way, and together constitute a very complex system to run. As an example, like telecommunication systems, you have these, obviously devices sending data to each other, or, in the market in general, companies are partnerships with each other, and so on and so forth. Or in our body, we have the, the neuron systems sending signals to each other. These are all like, systems where we have independent agents interacting with each other and together constitute a very complex system that runs. But if you want to understand any complex system, the first thing to do is really to make a wiring diagram of it, meaning, make dots and then links in between them, and use this little representation technique to start understanding the diagram, the infrastructure, the structure of the complexity. This is usually called network diagrams, obviously, and you've probably seen this anywhere. If you just search big data today on Google image searches, you'll find all of these diagrams. But I want to step back and really look at how it's really useful and how it's really actually can be used in your own work as well. So if you just take these three examples. The first one is just some devices talking to each other through their IP addresses, sending, messages, data, whatever we do today. Or take like, 3 or 4 people who are film actors who might be acting in the same movie. That's why they're connected here. And then take like some companies who are shareholders of each other, and this is also like, connected to each other there. So these 3 different systems, they have very different scope, they have very different content, but they have the same structure in terms of their dots and connections. Only 4 nodes and only 4 connections in between. So this is a very common and generic language that's both visual and mathematical at the same time. That means we can, by just looking at it, we can reveal some interesting information. We can start reading it, like any other image and text. And at the same time, we can make calculations on this image itself, which is itself data. It's not just representation; it's a data itself. So this technique basically is being used, for a very long time. In fact, in the world, like since the 60s, more or less, as far as I know, by the governments and corporations, around the world. This is one example of them. I got this in 2010 from a news article on New York Times talking about, it says police find a car bomb in Times Square. It was a bombing attempt, and then in the picture, what you have is like Obama with the NYP, New York Police Department, trying to kind of solve this thing. Actually, they pose in front of this image. In their background, they have a diagram of evidences, and some images connected to other images, maybe people, as well as some other events there. So they make a network diagram to understand, to kind of reveal they're trying to find this a solution, or maybe they investigate this thing using this technique. The mapping, this technique is again, available for governments and for corporations for quite a long time. But so far so good. All the tools that are out there and for network analysis were actually designed by the experts for the experts mostly. And that's why I started to think about this issue, and then started building tools for the really general public to be able to use this technique on their own projects and in data projects in general. And in fact, we know that today, like anyone who wants to do some reporting, some data research, you just go online, find different sources, and combine them into your Excel sheet or whatever, and then start analyzing that field, whatever your topic is about. So that's clear, it's out there. We all do this anyways. So of course, as at ODI, you already this is kind of your mission in this organization. You kind of promote open data openness, and so on, and the use of open data as well. But I think what's important is to have also tools that will help us to use that open data. That's kind of easier than what's out there already. And the other thing is, most in the past as well, this is today more normal, but many individuals and small organizations was considered really not technical, or didn't have data at all, or nothing to do with data at all. It was like a myth about data in general. So this is changing, obviously, and then more people and more organizations are aware of this, and people know that in their pocket there's a device that measures everything around us. So that means data is out there already. But the thing is, when the data is open and out there, yes, we can benefit from that. But the important part is when as we all know as well, when the data is interlinked, only then it starts making generating value, right? On its own as a list, it's not much, it's just some summary of things. But when you interconnect data to each other, when you link, basically, it's called linked data today, to each other, you start, correlating things to each other, which generates value, obviously. So that's why I've focused on this a lot, and then start building these platforms to basically and to interconnect our data to each other, and so that we can together see a bigger picture and whatever our cause is about. And GraphCommons platform started with this idea, and the name, I want to talk about the name a bit, why it's called GraphCommons rather than something graph. Because as you know, in the world we have all these things like Facebook's social graph, Google's knowledge graph, Spotify's music graph, some other companies' interest graph, and so on and so forth. But I think they are all proprietary graphs, as we all know. We don't own it. It's owned by these companies. So my goal was to really kind of reverse it and make it not something graph, but GraphCommons instead. So this is a platform where people can make different graphs, obviously import their data as a graph, analyze it, as well as interconnect it with other graphs, and obviously also publish it in this through this platform. The platform started with these workshops instead that I was doing for some time, workshops on how to make maps, network maps, and how to analyze network maps. I've been doing this since 2007, quite a long time now. You see some old versions of the GraphCommons interface on the video. And here people usually do hand-drawn diagrams first, which means they do like modeling. They do like kind of a model for their data at first in the network form. And then they start, bringing in data to that model, fit into the model, and start building a complex network diagram, which becomes their knowledge base. A network knowledge base that they can use, infer more interesting, results from as their research grows and so on. And so, at first we started doing this by hand, then with some kind of interim tools that I provided, and then finally, around 2011, I introduced this GraphCommons platform as a web platform where you can actually, within the browser, start, really making network maps and using network maps on your projects. Yeah, so this is what the website looks like at the moment. And when you enter, basically, there's a message and so on. There's a lot of examples here, because one thing that's really important is to learn from examples, obviously. So people here make maps, a lot of different maps. There are thousands of maps at the moment. And they are built by a variety of people in a variety of languages, from Turkish to Chinese to Portuguese to English, really a lot. And they are about a variety of topics. Usually investigative journalists are using these maps, activists are using it, small organizations are using it, NGOs especially, who wants to make organizational analysis sometimes, of their networks and so on. Sometimes they do research projects on its own, data research projects on this platform, and also, students obviously use it a lot, and a lot of design researchers also are employing these techniques in their own practice. This is the one goal from the very beginning, was to have this platform collaborative. So you're not just making on your own a map and publish it. You always start a map and invite people to kind of build it together. But it's not as open as Wikipedia in that sense that there's authorship is not so visible. You have heavy authorship in the system, where you can see who's making which map together and so on and so forth. There's always joint ownership of the maps, and no need to say the maps are always licensed with the Creative Commons licenses that are to the authors. They own completely the entirety of what they're doing there. And there are 3 ways to map here things. Like basically, use first. There's a what you see is what you get, like an interface, very simple, like visual interface, click, like the way you draw things. Here's a little example of that. You click on a canvas and enter some types, like I'm going to connect a person to another person, for instance. I click on one person, then another person, define what the relationship is about. It could be like collaboration, friendship, really many things actually. So I start adding these things, and on this interface, it's a physics simulation, software physics simulation. So there's a gravity system. Nodes move around based on how much they are close to each other, or how connected to each other, basically. And this is a very typical force-directed layout algorithm at the end, quite well known. There are many programs applying this technique. So this visual technique is basically showing you how to make a simple map, and then as you make it, it organizes itself, and then you have an idea of what it will look like over time. Of course, mapping like this, like manually, is not so easy when you have a lot of data. This is a bit like mind mapping level. So it's like you can really quickly sketch the same thing on a paper and pen, but it will until like let's say 50, 100 nodes. It will be very difficult. It will be very messy on paper. So it's useful to do it here instead. If you have more than that, which normally any research project has hundreds of information data type points in it, so you rather actually import your data from an Excel sheet to this platform to turn it into a network diagram. So we have these templates, like a typical spreadsheet or Excel sheet templates, where you can organize your data in a certain way. Every row is a relationship, like from person Burak collaborates to person Mark, for instance, is a connection, like the way I edit on the interface. I can just take this, and this can turn into a basic network diagram. This can take obviously like thousands of lines, and then it will be converted into an interactive network map right on when you import it. And thirdly, we have this for more advanced users. We have this API for programmatically enter data into this platform, or use data from this platform, because all the data out there which is public is there. You can query anything and then start inferring actually higher level knowledge from by querying these graphs which are out there. We also employ something called graph signals. It's for capturing any event into the form of a graph as it happens, and then I can talk about this later if you have any questions in that. It is also the documentation available on this website, graph.com/dev, is the API documentation. So once you do your work, when you create a map, the thing you do is like basically call people, invite people to kind of work on that together. That's the idea. Usually, there are many, a bit like Wikipedia things, but you, rather than editing text, you edit a diagram. You edit this visual system together, basically, this is one little screenshot showing that how people communicate with each other. We have this thing called comment bar on the right-hand side. People basically type in some things here. This is Turkish-English mix, I think. People, for instance, this is a map about Syrian refugees and what NGOs help, which container camps and stuff like that. So this journalist, they're actually making this map, and people coming to this page and actually kind of recommending these other links and other data points about, or actually ask for changes in the map. So the maps actually, when they start, they're a bit immature, and then over time they become something very useful, a useful reference over time as people add their information. When the maps are done, basically people, you can look at these maps in multiple devices. They're all interactive, touch, click, whatever you want to do. It's all available up there, and you publish your graphs basically to the world, which it means you kind of cache it so it loads faster and stuff. There's all that little technological things in it, but at the same time, when you share your maps on social platforms, they automatically get these cards and things, and then they become socially available very quickly. And of course, no need to say, you can embed your graph to your own websites, like a YouTube video. You can embed an interactive map into your blog post or website, to full screen, however you want. Just some examples: people using the graphs on their blogs, on Twitter feeds, make selections. And one thing to say is very important here, like any graph is usually a big world. It's not just a small or a story, This is important because usually we tend to think about these things as like storytelling tools, which is not the case. It's a world, usually a database. You cannot, tell the story of the whole database at once. It's impossible. So you always make captures from that, small sections, to tell this compelling story, basically. And then when people click on that, they come into your graph and whatever the section is about, and then from there they start exploring the other stories in other parts of the world. Okay, so we have this deep link system. That's why you can address any node with the full URL, and and you can share that. It becomes a shareable item on the web. As I said, you can embed them. This is one example. When the Prime Minister in Turkey has changed, this news agency, BNet, is a quite important one in Turkey. They only publish on the internet, but they're really progressive. And they shared the interactive map from their cover page as a news piece, and showing the Prime Minister's past work, which was Ministry of Transportation, and all their contracts they've done to the private companies and so on and so forth. They kind of published that as a big story, and this was used in as an interactive map on their cover. You can also make prints with these things, obviously, because they are SVG files, they are vector drawings. You can take that and put into your Illustrator program if you want to, and make a poster, big prints. I make a lot of artwork and exhibitions with this material, basically, where people can sit in front of these things and discuss. It's important to have prints because it's high resolution. The screens are only limited to your screen size. You have to zoom in, zoom out to really see the entirety of things. Making prints is really helpful, actually. Basically, you see the whole thing at a glance, and then zoom into it, and then get immersed into the printed material. Another example of print, for instance, a newspaper published a big corruption case in Turkey, and is the story. All the actors in the story are printed as a diagram and vertically on the page. And this was used as poster later on by students on their protests and so on and so forth. Print has this very nice political, actually, I think, effect in general, which we don't have enough in the screen or digital world. I will show you some actual examples now, like dive into the maps a bit. This was the overall, what the platform is about. One example, I liked this a lot. Again, this map called Syrian Refugees and the NGOs the NGOs helping them, supporting them in Turkey. As you know, there's a passage from Syria border to Turkey, and then all the way to Greece and European borders, basically. And you may know as well, there's a big deal the European Union is trying to close with Turkey to turn Turkey into a police country, to block all the refugee flow to the European Union. Actually, that's a big important issue at the moment. They want to pay around $5 billion and some euros or something like that at the moment. Anyways, but this map is about the cities in Turkey, Istanbul and other cities. They are mostly border cities. And the NGOs, international, local, national and local, and who are supporting in different ways to these Syrian refugees. For instance, we can zoom in. So I'm just simulating this interaction because it's easier to go through these slides. So when you mouse over a node, for instance, the city of Gaziantep, and you see its immediate connections highlighted, and the rest is turned off. So this way you focus on the particular diagram, particular area within the map. These are like the refugee camps, brown ones, and then there are the blue ones are internationalist organizations, and then the greenish color is the organizations from Turkey, national. You can see UNHCR and other organizations quite familiar are active here. And if you mouse over UNHCR from Gaziantep one step further into the network diagram, you see where else UNHCR is active in this context. And you can also type in the search what type of UN organizations are active in this topic. They are listed automatically. Type ahead, search within the graph. Some other cities and so on, you can explore it like that, basically. And as I said, like people come here and then write comments and then really say, for instance, Doctors Without Borders, as an example, was very active in Turkey naturally during this process. And then somebody from Doctors Without Borders came here and then said, we are actually not here but here. Can you change that connection? So they changed. The author made the change in the map, basically. And all these data is referenced as well in the notes. I'll come to that a bit later. I'll show you another example now. This is the media ownership in Turkey. This is the map. I've been also participated as a researcher in 2013. Here, basically, what you see is like the mass media channels, all the TVs and newspapers, and who's owning them, and what other contracts they have from the government. This is a very important, I think, relationship because, as you know, these companies never talk about the critical issues. The media companies never feature those critical issues if they have some interest in that issue, and through the government contracts, obviously. And this is more or less same everywhere in the world, I think. So let's zoom in. There's like CNN as an example. The CNN the Turkish branch of CNN, basically owned by this company called Doğan Holding, and they in fact own many other newspapers. Like Hürriyet is like maybe Guardian or something, maybe even more popular than that in Turkey, and they own these different newspapers. At the same time, they do a project, a power plant project called Aslancık, and in that project, which is contracted by the government, they are in partner with other companies, like you see here, Doğuş Enerji, Dolsar, and so on. Energy is like energy, basically. And if you go one step in these relationships a bit further, you will see that Doğuş Enerji belongs to Doğuş Holding Company. They have similar names, but they are different holding companies, quite huge. And you see Doğuş Holding also owns different news channels like CNBC and so on and so forth in Turkey as well. NTV, as an example, is the top TV channel at the moment, kind of competing with CNN within Turkey. Of course, they manipulate the public opinion. Obviously, it's now news, but this is the rationale, why they manipulate the public opinion, I think. So zooming back, this was the area that we just looked at, and this is a really quite a large map, a large world again. So you can only tell this small stories and then navigate from the small story to the larger picture using these interactions. And these nodes also contain detailed information in them. It's not just there like dot and a line. When you click on a single node, you see that it contains a lot of other biographical or portrait-like data points. This is the information card, basically. It's what we call node card or information card. In that, it says this is the third airport built in Turkey Istanbul at the moment, and then it started in 2013. It has this much of a budget, and it's actually these are the data sources that you can click on. And there are other relationships which are saying that these are the companies who are building this project, basically, or who got this contract from the government, in other words. In the newest iteration of this work, we have also financial organizations who actually fund this construction. It's a huge construction. And this is like, as an example, like the third airport is here, and then around the third airport you see these certain companies, Kolin İnşaat, Kalyon İnşaat. İnşaat means construction. And then these construction companies together built this huge, giant project, and at the same time, if you just expand a bit more, you will see they also own media channels. So this project I showed you was part of this actually a larger project called Networks of Dispossession, and there are like more than 30 maps now like this. Like media is only one aspect of it. There are other aspects like the food and market chains and stuff like that. These are other things that we also architects and stuff. Are other data points and aspects we looked at in regard in relation to this topic. So the thing about Graph Commons is that when you have a large project like this, which have a lot of data points and and interesting aspects, you don't just make one graph, but instead you build a knowledge base, a database, actually a graph database for your project, and then make a lot of different views to this, and which are all graphs. And then also stories as well. And these are some of the examples. And organizations also use this system, not just projects. Like as an NGO, Helsinki Citizens Assembly. A simple project is from Zurich University, a research laboratory. And SALT is a cultural institution in Turkey who are doing cultural research in general, art and culture research. Here's a foundation from New York doing art granting overall, and they map the impact of their grants and so on. And they have special pages, what we call hubs, basically data hubs for these organizations or projects. This is another example, very different topic now. Here we see the Simpoy from Zurich University. What they do is they map the European Union policies on climate regulation. Or climate and finance regulation. For instance, the red dots on the center are the policy proposals by the European Union, and then there are consultations around them. Like basically, companies are asked to respond to these policies, and they have some opinion, some report, for instance. And from those reports you can understand if they are supporting or are opposing these policies, basically. So, for instance, when you focus on one of them, again, mouse over carbon tax as an example, you see among all the different companies and organizations, Shell is the only one who's opposing, as an example. Not so news. Oh, there's one actually here as well. I think a German company. And if you go to another, for instance, more popular policy, people and companies have very different opinions. There are also NGOs here, like Greenpeace and so on, not just companies. And if you focus on one of the companies, for instance, instead, you can see the quite quick list of what Shell opposes, what it supports. As another example, you can easily navigate from one company to another or one policy to another, so you have this different point of view in a single map. Yeah, that's about it. I'm going to switch to another topic now and then finish it with, I think, one step later. So we also look at the government data, especially in Turkey, working with so there's a government website like any other country, like the data.gov, UK, you may have that. We have a similar thing. So we scrape data from these pages. It's quite complicated, but we figured it out, and then it works so far. What we collect is all the profiles of the parliament members. Historically, it goes back to 20 years. And we collect all the policy proposals they have, what they signed actually. It's also collected. So it's a big network of parliament member and their signature or signed document, basically. And there's more of that. And so we put them into this one of these hubs on Graph Commons as a graph knowledge base. So you can actually use it for many reasons, actually, at the end, Parliament. So one thing we did is one time, this is a news piece, says that this company called Katmerciler Holding here is actually also the producer of Toma. The Toma means water cannon tanks, basically. And they also do a lot of tear gas production and some stuff like that. So they made big revenue that year, 2015. And as we see this news, very interesting. Okay, let's look at who's these guys behind Katmerciler Holding Company. We found that these people, like these people here, are the board members of this company. At the same time, they are the parliament members and from the current government, which is AKP party, AK Party. Here it is. Yeah, those four guys. They are the board members. They are the owners of that company, which makes a lot of money from public control, protest control systems. And they also propose a lot of different laws. You can take a look at that. This is one little policy proposal they all signed together. And you can, in this little card, because it's all captured automatically from the website, there are references, numbers, or even links to the PDF files that we captured earlier, and so on and so forth. So the public can actually, compared to that news, they can actually see this type of mapping, logic behind that, and then start exploring these guys and their, what they've done in the parliament. Yeah.
Could you translate the title?
It says Katmerciler. Katmerci is the company's name, holding their, and then their board members, and their board members' activity in the parliament. It was a bit weird translation, but yeah. So you can focus on these guys and what else they've done. You can expand their different connections that we captured from the parliament activities. The other thing about parliament, one more thing we've done is the actual activity on the stage of the parliament. There's a little place where you give a speech, and that's where you also have immunity, total immunity. So no one can touch you. Whoever touches you will be jailed for sure. Doesn't matter who they are. It can be a prime minister or anything. So it's very important to speak independently there, like the House of Commons, I guess, have similar rules. So what we do there is basically this is also recorded. Whatever you give a speech in this, in this place, and everything is recorded. All the reactions are recorded, and they are typed actually, and then published automatically on this website. So we captured that as well, and actually I organized a workshop, which is this was done in that workshop, where the participants made a map of who says what about whom, and then also it's like a semantic analysis of the text basically, and turned into a graph structure. From the written text. Basically, what we looked at is not just the topics, but more the reactions of the audience to the speaker. Sometimes they clap, sometimes they, they hit the tables and stuff like that. They make noise. It's all out there. And so these are different parties, different dominant parties. Red dots are the people, the MPs. Green dots are their speech. So they had a lot of speech points, and each speech point has connection to an MP, obviously, and then to other parties who reacted them. And parties usually react as blocks. One party completely either claps it, or completely, just shouts at them, and so on and so forth. And if you zoom into the details, you'll see this is the title of the speech. It's about something budget, there's some discussion about budget basically in some topic, and then this guy, Aykut Erdoğan, is the person from CHP party, and he's doing the speech, and then there are different reactions from different parties. This is a huge, large graph actually. You can zoom into any of the MP or a speech or a particular party, and then start exploring the activity in the parliament stage basically. It says like noise coming from one direction, or the clapping from other direction, and or speech on this direction, and so on and so forth. There's some details from that. Okay, that's about it more or less. This is what I wanted to show you, and then because I didn't go too much into artistic practice. I wanted to stay more on this platform side, let's say. And we can a bit discuss if you have any ideas or questions about this. Okay, thank you.
Thank you so much, Burak.
Yeah.
So the reason I have a microphone is actually not to amplify my voice in here, but so that people watching on the YouTube stream can follow the proceedings here. So if anyone has a question, I'll ask you to do the same. Thank you.
Hi, thank you for your talk, which I found very interesting. I have just had one question regarding the structure of the graph. I was wondering whether the interactive graph that's presented also has some mechanism by which it would be possible to assign a weight to the edges between two nodes, so that a user can work out whether a particular link is, not only there's a link between two nodes, but the strength of that link.
A good question, yes. You can add weights to the connections as well as directions to the connections, both ways. So I think in terms of like my communications, for instance, if we have frequent emails, we can use that frequency as the weight of our connection. Or we can assign like an abstract scale, like from 1 to 5, and you can say this connection is 5, this connection is 1, this connection is 2 and 3. So there's this both ways of making edge weights or connection weights between things, which also is used in the layout algorithm for calculating the proximity between nodes and stuff. Yeah.
Thank you very much for your talk. I'm just wondering what the balance between automated presentation of information and interpretation is. And I was wondering this in the context of the parliamentary speeches. So how does the information about responses get introduced into the graph? Is that through notations in the transcript, or is that through interpretation by a journalist? And the kind of follow-on is what interpretive skills are necessary to either participate or to interpret these graphs?
Thanks for the question, it's a very good one. So the parliamentary speech text has notations in them by the person who's typing it, I think. In parentheses, they say the reaction. So we only capture that part. It's not semantic analysis, just looking at those notations, the parentheses. In between it has something, so it's repeating the same basically words. So from there you can extract what the reaction is about. That was how it was actually extracted. Regarding, you said, how people explore these things, it's not easy. First of all, normally all these speeches are, of course, broadcasted on TV and also online. You can watch the whole parliament speeches from YouTube videos and stuff. And we didn't try too hard to really push this information out, to be honest, but people, whoever discovered this from social media links and stuff, and just start exploring this. And then what they do is that they look for a certain topic. They type ahead on the search and then find this speech point, and from there they find who's giving the speech, and then also what the reactions are to the speech, basically. And if they are more interested, there's a full text link to the full text of the speech itself. This is how it was being explored. There wasn't really an analysis of it, like on top of this, but our goal was to really push the raw data itself in this graph format first. Maybe later somebody will do the analysis on top of that. Yeah.
Any further questions?
Oh yeah, thank you for the talk. I don't know if you covered it with the aid groups working in Turkey, but can you do this overlaid onto a map? So they're actually geolocated in the right location and still connected, sort of in a theoretical line.
Yeah, so it's a very hard thing to do before anything, like combining a geographical map and a network diagram, because normally it's too arbitrary, because on network diagram you try to organize the nodes, the layout based on the proximity between things. The program works that way. But in the geography you have fixed node locations, obviously, for any geographical tag things. This works together only if there's really a physical connection between the nodes, basically. This is just logically, but with the new version of GraphCommons, we make a lot of releases often. So I think in 2 weeks we'll have a geographical support. So you will be able to have the network map on top of our actual geo map, basically. And I've done myself work like this in my actually current exhibition in Manchester right now. There's one piece about the mosques. mosques have geolocations. Obviously, there's 3,000 mosques in Istanbul, and I made a map of the mosques and how their sound, the call to prayer sounds, overlap. This is a very physical and also relational connection. That was one good example of use of this. And I think usually flow diagrams, like human flow or material like flow, could be also mapped like that.
Supply chain solutions.
Supply chains, yeah.
If you're a car manufacturer, you need this 1 of 5 factories, and whatever you want to know, whatever, which one.
Exactly, yeah. So for these reasons, we are actually releasing this feature where we have the geographical and diagrammatical things on top of each other, basically.
Yeah. Okay, cool. Sorry. Actually, on that point, does it often result in a lot of data points being sort of overlapped, especially if there's sort of refugee support or something? They all end up being in the same place in a lot of sports, quite heaped on top of each other. So it doesn't look. It's not very clear, the data that comes out, if it's geographically mapped, right? Is it quite heaped?
That's true. I mean, geographical maps and diagrams, when you combine them, it's really messy. It's clear because you cannot move things because they are fixed to locations. You have to zoom in to really see the details into this. I think zoom helps in general to get rid of the clutter, but usually it's very difficult to look at from outside.
You use like a sort of Z-axis where you have a sort of 3D view and you have pins that sort of lifted up from a location or something. I don't know.
Yeah, 3D view is also very difficult because in these maps, the one point is to make it 2D, especially is the size of the nodes represent some information. For instance, number of connections they have, that shows how important they are within the diagram, or the betweenness centrality, how bridge are they in between clusters and stuff. So you can assign those values to the node size, which makes a big, different. You have different node sizes. When you make it 3D, you lose the depth, actually the size comparison, because the big one is on the front or in the back. It's all mixed up. So that's why it's very tricky to use 3D. 3D is only good for navigation, not for representation, to be honest. Like, I don't think it tells a good story. Well, it tells a good story because you navigate in 3D worlds, but it's not very effective. I mean, you have this analysis perspective.
You do like, was it parallel projection rather than perspective views, right? I guess to lose the perspectivization of sort of distance.
Parallel projection, what does that mean?
Parallel projection of it. It's like sort of 30-60 or 45-45, where you don't have perspective. Basically, it's all mapped. And it stays the same size.
Okay, it might be a good technique to try. Yeah.
Hi, I've got a few questions from Twitter. Stuart from ODI Leeds has asked, does the site have any limit on how many connections a dataset can have?
So each graph basically is limited by the browser capacity and then your computer capacity. Normally, I think with the current technologies we have, you can very easily have a graph that has 500 to 800 nodes, more or less, and many connections in between. If you go further, like more than 1,000 nodes in a single graph in your browser, it could be a bit tricky and difficult. But we have this thing called WebGL technology, which actually uses your graphic card to runs things faster and so on. So with that, we also improve up to a couple thousands actually. But the thing is, there's a perception problem then. You, as a person, a viewer, checking out these maps, where to look at it becomes a bit difficult. As the author, you can really use that in high numbers like that, but you might have challenges when you are trying to publish this story or this whatever map to the world. People will not get it easily. That's more like a perception problem.
Thank you. And one from Beck Strickland, who's asked, can you import a CSV of data containing the nodes and relationship information, or does it have to be added manually?
So you can, as I said a bit earlier in the presentation, there's an import option where you can import a Google spreadsheet or actual Excel CSV file into it, and not just for relationships, but also for the node details, like for the cards that I showed earlier. And then when you import it on top of the existing graph, it will update if it actually matches the actual data points. There's more information about that on the Graph Commons blog, blog.graphcommons.com. Actually, I think it's, I can show it from here, yeah.
Thank you. And then finally from ODI Ottawa, quite similar to what you asked. Does Graph Commons support/plan to support temporal graph data, enabling graph evolution or change visualizations?
So temporality is a very challenging thing to do in the graphs usually. But I didn't show here, but we have a timeline option. So in timeline, basically your graphs can be animated as time changes. So you can actually observe a graph of a network diagram. And as long as you have data about time, basically, you can have your node's properties set. You can set your node properties some number or some time element, and that's how you basically have time in the graph. And then if you have that, you can use filters to filter the graph into a certain time limit, or you can actually move the filter and so on, and have an animation in between. Yeah.
Question over here.
Yeah, I wondered if you tested or if you had plans for the inclusion of reportage or testimonial. I think there's a project that's been running a long time called Ushahidi, which is around testimony particularly from Africa, from people talking about what's happening on the ground in a sort of local journalism reportage style. And so I wondered if there was an opportunity for pulling in that kind of witness testimony, either in free text or in the form of photographs or something, whether there was any possibility of that.
It's a very interesting question. In a way, it goes as a bit like crowdsourcing idea, basically. But it's possible. I mean, because they have the API before everything else, you can write a program as a new service that can do this, that can transform like your existing, even you share his existing data into the diagram. But also, because our community is mostly involved, these like people, journalists, activists, and organizations and so on. There's kind of a demand like this at the moment, and I think we're planning on some new features that will kind of address this a bit. So currently, as an example, there's one experiment already done in this area. On Twitter, when you use a certain Twitter structure, a tweet structure, like hashtag something, add something, another hashtag, which is a connection to another add something, you can start making connections with the tweet itself. Somebody wrote a program for this actually, and so you can actually tweet connections, between entities and whatever the entity is about, and that becomes into a graph, aggregated into a graph, and so on. So this is one way of doing this, I think, an easy way, because everyone uses Twitter these days. But we may have more explicit features that support this type of activity. I think it's a good idea in general. Yeah. Of course, there's always a problem of data quality and the references and so on and so forth. And there's different ideas about that, like how to secure the data quality, because when you say something it's not true, or we don't know, if there's no reference, you cannot really trust on that information as well. One more question this way as well. Okay.
Hey, it's a really interesting talk, thank you. From the kind of journalistic point of view and the use in newspapers and stuff, has it been used for just kind of a visual explanation to the public about how the connections are made, or has it actually been used to throw up unknown connections between different companies, politicians, through corruption or other such? And has there been any changes that have come from the use of the data? So I'm thinking like change of policy, or bringing down of politicians.
Not yet. But some things we know. For instance, as an example, the media ownership map was quite effective in Turkey. It became very popular. Like literally, 50,000 people were checking this out in a day or something like that in one of these hype moments. But no one resigned or anything like that. But we know the companies, people who work at the companies, they check these maps. I know this through friends who work at these companies, who are lawyers and so on and so forth. But the thing is, this data, we never had any problem, by the way, from the government either. So it's interesting. Maybe governments and corporations don't care about this. They maybe take it as like a market analysis platform or something like that. We don't know about this effect yet, but it definitely creates awareness. Definitely creates very solid discussions, And I think it has effect on the activist community at all, because there's all these ecologists and the ecologist activists in Turkey, as an example, who defend the forest, the water, and so on and so forth. They had really, I think I can tell that they've been using this language of relation or indirect relationships between entities a lot now in their protests, in their campaigns, and so on. And that means they focus on the companies, not just the issue itself, but the proponents and all the other people related to that into the campaign. In that, it creates some literacy, I would say, but yeah, not direct effect on the I don't know, at least if companies were affected or not, really. Yeah. That was yeah.
Thanks. You did say you were holding back from discussing it as an artist project, but I would like you to see if you could go into that, because
Sure.
My reaction kind of relates to using it journalistically, was also how this is something that can be developed by an artist as a programmatic exercise, because there is a tradition of artists using the exhaustive mapping of social and economic relationships. One particularly thinks of Hans Harker in relation to art institutions in New York, and also Martha Rosler's project, which has gone on for really 30 years now, and obviously has morphed into a much bigger presence through social media than actually something that had started as being a gallery exhibition to exhibition mapping project. So if you could just say a bit about how it works for you as an artist project.
So like I can maybe give examples from my current show in Winchester right now, which is showing many examples actually. But one thing I've done in the past, as an example, is but before everything, I'm definitely influenced by people like Hans Hacke, Guy Debord, who use psychogeographical maps in this format, diagrammatic connections between geographies. Or Mark Lombardi, for instance, another example, who done analysis of news articles to make up these interesting analysis, or George Massinas of Fluxus movement, for instance. They were also doing all this historical analysis of their own movements, like legitimization and so on and so forth. My work is more focused on using data rather than the map. Is definitely one way of showing this, but that's not my point really. I use that just to communicate this a bit, rather than that, the research, the data that is generated with this work, and then I, as an artist, I don't as an example, call myself a data visualizing person. I actually create data, new data, about whatever the topics I'm focusing on. That's one thing, and I write software. That's the other aspect. I write software for my work, which is sometimes performative, sometimes just making predictions automatically. One example is this project called My Pocket that's currently on show again. It's a software that predicts what I'm going to buy next every other day. That's a live performance. I actually live with this program, and as I swipe my card, the data goes into some financial cloud, and then from there it goes into my bank. I can see it from the bank and use that data to make new predictions about my own spending, as a critique of this current situations we have at the moment. Things like that. I use it a lot. I combine software, data, and performative things like that. And one time, maybe another good example, on the art world itself, self-criticism of the art world. I've done work on artist and collector relationships. For instance, I looked at the art collectors, and what artists they have in their collection, and then what other collectors are they in, those artists. I made these maps of artist-collector relationship. But for instance, for this work, I had to go and convince these collectors to share this information that's actually private most of the time. These are not museum collections or whatever, just individual collectors' pieces. So And that work had many versions, and I show that work every time I show it. Actually, I ask the institution to help me find more collectors who I can get data from, and so on and so forth. It shows the influence of collectors in the market. Obviously, you can trace with the same technique which artist is more central, which collector is more central or more in the periphery, and so on and so forth. They're all quite visible. And this is raising new questions about the market forces in the art world, for instance. So different examples.
Well, I think that brings us to the close of the event. Unless there's any burning questions online or from the floor, have we got any? I would just like to say thank you so much.
Thank you. Yeah.
And I think in the spirit of Tim Berners-Lee's ambition for the World Wide Web, that it is for everyone, I think we can all really show a hand of appreciation for the way that you're progressing that.
Yeah.
Thank you.
Thank you.